Hello everyone and welcome to Cloud Bootcamp. This is the lecture number 6 in Google Cloud Platform series. And today we'll be starting off with Google Cloud Networking, which is called as Cloud VPC, Virtual Private Cloud. First, basically, we'll cover some basic stuff related to networking. Related to Google Cloud Networking, before we dive into it, I think you should have some fundamental idea about what is network, what is IP address, and what is RFC 1918 standards, because these things we are going to heavily use within Google Cloud Networking. So before we learn about networking in the context of Google Cloud, let's try to learn about these concepts and let's get a very high level overview about what is network, what is IP address, and in a simple term, what a network looks like or something like that. So these are the learning objectives for Google Cloud Networking or Cloud VPC topic. First, we'll be discussing about basics of networking, as I mentioned. Then we'll move around overview of Cloud VPC. We'll just see what a subnet in GCP, and we'll create a VPC network in GCP to see how the look and feel is. Then even we can create some firewall rules to see. Then we'll move ahead with shared VPC, which is a very unique to GCP and a differentiator from other cloud. This concept is currently only available in Google Cloud Platform, and Azure and AWS it is not available as of this recording. We'll also talk about VPC network peering and Cloud VPN and interconnect as we move ahead. So as I mentioned, first we'll cover the networking basics. So what is a network, IP address, CRDR ranges, and RFC 1918 standard. So then let's try to learn what is a network in a simple way. But before that, let me just take a snap of this router and just wanted to put it in my pane. Let me open the pane symbol. So I'll just write it down so that we remember what we are learning. What is network / networking? And let me paste that image because that's an important image. This might you have seen somewhere in your home. This is called as a router or a Wi-Fi device, for example. Router Wi-Fi device. So you might be having this device at your home, as I mentioned, right? This is just a kind of router on a higher level, and this device helps us to connect all of our devices. Let's say suppose we have a laptop over here like this, and we have a desktop maybe, or like this, and then maybe we have a kind of mobile, because mobile also connects with the router, right? So if I just write it down, this is a laptop. This is a desktop or computer. This is your mobile. So as I mentioned, like Wi-Fi or the router will connect all of our devices, right? So if I can just connect these devices. So when all the machines or devices connected together, right, with the router, this is a simple example of a network. Like this router is connecting to your laptop, mobile, and desktop computer, and so on. So this is, in a very layman term, this is called as a network. So if you see in your home network, like you may be reaching out a website from your mobile. For example, from my mobile, I am just trying to reach from my mobile, I'm just trying to reach maybe www.google.com, for example. So I just wanted to discuss like how this network will work. Like maybe from your home network, you're trying to reach from your laptop or from your mobile, in this example, to a particular website, right? Like google.com. So whether it's your laptop or it's your mobile device, first it is going to connect with this router. So once you run www.google.com, right, first it will connect with this router. And afterwards, it is going to connect with the public internet. So for example, let's say now this router will connect to the public internet like this. Once you hit google.com, let's name this as public internet. And now what happened is now still the perimeter which is over here, right, from here to the router, this is still your private network. And from here, as you have given an instruction to hit google.com, right, now it is going to the public internet as such. And this means you're going to the real internet to the public internet. And now your request will travel to different number of hops. So let's say suppose once this router goes to internet, right, there may be different service provider in between this request, which then will be forwarded to the google.com server. Like this can be your google.com server, and let's name it google.com. And maybe this can be a data center situated in the US, for example. For Google, it can be Silicon Valley. And eventually, this data center will return the home page of google.com back to the public internet first, and then eventually it will return back to the router. And your router or the Wi-Fi device will return back this google.com page from where you have tried to access. Like in our case, we were trying to access from mobile. So as I mentioned, right, if it's over the public internet, it can travel multiple hubs eventually to reach your router. And at the end, this router will send the message to your respective device from where you have searched for google.com or any other web website as such. So this way, our home network will work. I hope this concept was quite clear on how your home network works, right? So this is not related, like we haven't started the Google Cloud Platform networking yet, but my idea was to give you at least an overview of what networking is and how our home network works as such. So now we have a basic understanding or idea of the networking, right? Then we can move ahead with the further concepts of networking, which is like IP addresses and CIDR as such. So let me move the screen, or let me go to the next slide. So here we see, like, we are trying to understand what an IP address is as such. So if you see, it is just a 32-bit representation. And before that, before we started off with the IP address, right, let me go to my Chrome browser and see the IP address of my laptop. So if I just go over here, what is my IP, for example, and if I just hit on this link, right? So you see, this is my laptop IP address. This is my laptop IPv4 address. And we'll just copy this, although I have it in my slide. And I have just mentioned it over here, like this is my laptop and this is my IP address. So let's take an example, like consider like you want to send some email, right, to anyone. Then definitely you should have some kind of destination email address whom you want to send an email, and you should have some kind of source address. But how you can define this address in the context of internet, right? So every single machine on internet has been given a unique number. So for my machine, my unique number is this. Like in this website, we have seen this is my unique number or IP address, yeah? And this is how uniquely my machine is identified. So let me go back to the presentation, and I've included the link over here, don't worry. And this IP address is nothing but specific to my machine itself. And now you might be thinking that how this IP address is represented, right? We'll come to that. But just try to see those bullet points. It is a 32-bit representation. And how it is 32-bit is like you have this 103 is 8-bit, this 174 is 8-bit, this 141 is 8, and this 233 is 8. For the time being, you can skip this or don't worry about this /28. I'll come to this point. And how this 103 is 8-bit is, you see 103 is represented as 01100111. This is how a binary representation is done. And if you want to see how we can convert this binary, right, to binary, let me go back and let me just CIDR.xyz. This is a very good website for you guys. And if I just paste my IP address, which is 143.101.141.233 141.233. Leave this /28. This is nothing but a CIDR notation. I'll come to this point. So you can see 103, how it is represented in binary. So if you want to see binary of 100, right, you can just write 100 and it will automatically give you the binary. So that's how you can get the binary. This is a very good website for you guys to get it. And this shows, like, with this CIDR notification, this can be my first usable IP. This can be my last usable IP. All right. So, and I've just added this second pointer, which is like IPv4 means 4 number. I mean, just trying to represent this. This is just for you guys to understand the IP address in a very layman term. The 4 number is 1, 2, 3, 4. Yeah. And with IPv4, we can have 4 billion address being represented. Keep in mind. And nowadays, we have lot many devices coming up where we need more IPs, right? And that's why we have IPv6 also in place. This is a different topic altogether. If you want to know more about IPv6, you can just Google it to know more about it. But yeah, just thought to call it out over here. And if you want to see your machine IP address, you can just hit this website and get to know about your own IP address. So now with this knowledge, I hope you understand what a network is, how an IP address is represented, and how a network connects, and how we talk to the public internet if you are hitting any website or any other services as such. And let's see more about RFC 1918, because this is quite important to know more about the IP address. So this is nothing but request for comment 1918. It is just a standard wherein your private IP address space is being standardized using this RFC 1918. So this is just a standard for representing your private IP addressing and not the public. Keep in mind. So this is the definition. Like RFC 1918 was used to create the standard by which networking equipment assigns IP address in a private network. Yeah. So these RFC 1918 IP private IP addresses are not routed on the internet. If you try to route those ranges on the internet, right, internet routers immediately block or discards this private IP address ranges. And you might be wondering like what these private IP address ranges are, right? So if you see, this is the block of the IP address along with the CIDR prefix. This is the class A IP address range, which starts from 10.0.0.0 to 10.255.255.255. And how many IP addresses in this we have is like this figure. Similarly, for class B, the IP address range starts from 172.16.0.0 to 172.31.255.255. And these many IP address ranges are there in class B. And similarly for class C, this is the range, and these are the CIDR prefix. I'll come to the CIDR notification and then you can get more idea. But class A ends with /8, 10.0.0.0/8 over here. This means in this CIDR prefix, we can have these many IP address or ranges as such. Similarly for class B and class C. Let me move to the next slide real quick. Yeah, this is the CIDR. So as I mentioned, CIDR is nothing but this /28 is the range, and this is the IP address. So if you could see, I've mentioned over here, like a CIDR block consists of a starting IP address. So in this case, starting IP address is 123.52.36.0 and a range. Range is /28. So CIDR block is just a way of expressing a range, which is this, of address that resources in a network can have. So you can have these many ranges assigned to a virtual machine, a bunch of virtual machine, right? Which can have IP address from this range. And if you need to know how many IP addresses does this CIDR block have, is how you can calculate is, this is just an IP range 123.52.36.0 and /28 is the range, as I mentioned. So what this /28 is, these are the 28 bits which are fixed. And if you go back, I've mentioned like IP address is a 32-bit representation. So from 32, we are fixing or reserving 28 bits. So how many bits are available with us? So it's 4-bit. And what is the formula to calculate the total IP address which we can use out of this CIDR is 2 to the power n. And n over here is 4, yeah, which is 2 raised to 4, which is 60. So I have also mentioned like to find out how many address does this CIDR block like 123.52.36.0/28 have is, you need to have 28 bits which are fixed and 2 to the power 32 minus 28, which is 2 to the power 4, which is like 16 address from starting from 123.52.36.0 to 123.52.36.15. We have mentioned 16, but it is starting from 0 to 15, so it is like 16 IP addresses as such. So if you want to take another example like which is like 123.52.36.0/31, and as I mentioned, we have 32-bit representation for IP v4 IP addresses. So here we have mentioned it as 31/31, so that means 31 bits are fixed, and 32 minus 31 is 1 bit is variable, and the total IP address is 2 to the power 1, which is 2. So if we are using /31, we can only get 2 IP addresses in the networking world. And if we are using 0.0.0.0/32, wherein 32 bits are fixed and 0 bits are available, because 32 minus 32 is 0. So total IP address is 2 raised to 0, which is 1. And if we take this 0.0.0.0/0, where 0 bits are fixed and 32 minus 0 is 32 bits are available, so total IP address is 2 raised to 32, and this is the number. So I just thought to give you a basic overview about the networking. In the next video, we'll learn more about Google Cloud Networking, which is Cloud VPC as such, Virtual Private Cloud. But this is quite important, as I have seen many guys, they are not clear about networking concepts, and if I started off with directly with VPC network, it may happen that some concepts are not clear, like what is IP address, what is network, and RFC 1918. I hope this video was informative, and I'll see you in the next, and thank you so much for watching.